Hi everybody, welcome to my channel. This is Oliver. We're learning algebra by working through problems. This is section 2.7, practice B, which is about square roots. So let's start. Evaluate the expression number 1 plus minus square root of 81. We know the multiplication table 1 through 10. So we know that square root of a number, let's say b, is a if a squared is b. Okay, so square root of 81 is 9. Why? Because 9 squared is 81, and then the plus minus here, so it's plus minus 9. Okay. Number 2, plus minus, and then square root of 25 is 5, because 5 squared is 25. Number 3, minus square root of 400 is 20, because 20 squared is 400. So 2 times 2 is 4, and then 1 0 converts into 2 zeros within the square root. Square root of 625, that's going to be 25. One of the numbers that you have to know square roots are, well, you know up to 10 squared, right? 1 squared through 10 squared, you should know through the multiplication table. And then 11 squared, 12 squared, and so on, right? So the numbers that are very often used are these numbers here, at least the ones I've seen, then 25 squared and so on. So 11 squared is 121. Maybe you should know these 5, 6. 12 squared is 144. 13 squared is 169. And if you're not sure, you can always check on the side here. 3 times 13 is 39, and then 1 times 13 is 13, so 169. Then 14 squared, 196, I believe. So let's say 14 times 14. 4 times 4 is 16. 6 and 1, 5 and 14. So 196. Yes. So it's 196. 15 squared is 225. And then 25 squared is 625. Okay. So number 5, 4900, square root of 4900. That is 49. Square root of 49 is 7. Right, and then 2 zeros within the square root convert into 1 0 outside of it. So 7 times 7 is 49, and then 1 0 converts into 2 zeros, so 70 squared is 4900. And then number 6, I have plus minus square root of 169. We said it's 13, so 13. Number 7, approximate the square root to the nearest integer. So this is close to 25, and we know that 5 squared is 25. So so it's, let's say here on the side here, so 5 squared is 25. So 25 is less than 29. How about what's greater than 29? That's 6 squared. 6 squared is 36. So we know that minus square root of 29 is between 25 and 36. Now, since this is minus, these have to be minuses. Now, this is minus 5. This is minus 5 here. Square root of 25 is 5, minus 5. This is minus 6. Which one is greater, minus 5 or minus 6? Minus 5 is greater because on the number line, remember on the number line, as you're going to the left, the numbers get smaller and smaller. So minus 6 is to the left of minus 5. So minus 5 is greater than minus 6. So minus 5 is greater. So the signs will be like this. Okay, so minus 29 is somewhere here between minus 5 and minus 6. And then which one approximate the square root to the nearest integer? Is it closer to 5 or is it closer to 6? Well, from 25 to 29, there is a 4-unit difference. From 29 to 36, there is a 7-point difference. So it's closer to 25. So we say this is closer to minus 5. So this is approximately, and then we just say like this, approximately minus 5. That's the answer for number 7. Number 8, 108, square root of 108. We know that 10 squared is 100. So let's do it here on the side. I'm just gonna remove these here. And 10 squared is 100. and then 11 squared is 121. So it's between 100 and 121. So we say 108 is between 100 and 121, and then it's closer to 100 than 121 because there's a 8 unit difference here, and this is 13 unit difference. So we say that it's closer to 10. So this is closer to 10. Okay, because square root of 100 is 10. So square root of 108 is closer to 10. It's approximately 10. Number 9, this is, we know 7 squared. 7 squared is 49, and then 8 squared is 64. So 53 is between 49 and 64. So this is so minus square root of 53 is between 49 and 64. These have to be minuses because this is minus, and now this is minus 7, this is minus 8. Minus 7 is greater than minus 8, so the signs will be like this. And then is this number close to minus 7 or minus 8? Well, this is 4 unit difference, this is 11 unit difference, so we say it's closer to minus 7, so we just say it's approximately minus 7. That's number 9. Number 10, 138, so we know 12 squared is 144, so 138 is between 121 and 144. So here I'm going to say square root of 121, and then on the other side square root of 144, and this is 11, this is 12. So square root of 138 is closer to 11 or 12? It's closer to 12 because the difference between 144 and, and 138 is 6. The difference between 138 and 121 is like 17. So that's why we say square root of 138 is approximately 12. Number 11, this is minus, and the square root of 55. 7 squared is 49, and then 8 squared is 64, so it's between, so we say minus square root of 55 is between 49 and 64, and these are minuses. This is minus 7, this is minus 8, minus 7 is greater, so the sign is like this. And then 55 is closer to 49, so this is minus 7. Okay, and then square root of 640, we know that 25 squared is 625, and then the next one is 26 squared, which is going to be what? 26 times 26, 6 times 6 is 36, 6 and 3, 6 times 2 is 12, and 3, 15. 2 times 26 is 52. 6, 7, 6, 676, 676. So this is between square root of 640 is between 676 and square root of 625. So this is 25. Oh, this is 25. This is 26. So square root of 640 is closer to 25 or 26. It's closer to 25 because the difference between 640 and 625 is 15, and here the difference is 36. So we say square root of 640 is approximately 25. Next, 13 and 14, tell whether each number is a real number, a rational number, an irrational number, an integer, or a whole number. Let's start with whole numbers. So whole numbers are 0, 1, 2, 3, all the way to plus infinity. Here, minus square root of 16, that's pretty much minus 4, right? And then square root of 9, that's 3. So whole numbers, in this case, is just going to be 3 or square root of 9. So whole numbers going to be just 3 or square root of 9. Then integers. Integers are negative infinity all the way to minus 3, minus 2, minus 1, 0, 1, 2, 3, all the way to plus infinity. So that's going to be minus 4, which is minus square root of 16. 3.2 is not, it's a decimal. Minus 3.5, minus 3 over 2 is not, it's a decimal. And then 3, it is an integer, or square root of 9. In this case, square root of 9. Real numbers, all of them are real numbers. Okay, all of these are real numbers. And then rational numbers, irrational numbers. We don't have irrational numbers because all these numbers can be represented as a quotient of two integers. Real numbers, all of them. Rational number, all of them. Irrational numbers, no. We don't have any irrational numbers. Okay, number 14. Whole numbers, integers. Okay, so square root of 5, that's going to be an irrational number because it cannot be represented as a quotient of two integers. So that's going to be the irrational number, square root of 5. Minus 6, 2.5, and then this one. Okay, so whole numbers, we don't have any whole numbers. So nothing here, no whole numbers. Integers, minus 6, and that's it. Okay. And then real numbers are all of them, because real numbers is a set of all the rational numbers and all the irrational numbers. Okay, and then rational numbers are all the numbers but the irrational numbers. So we said there is square root of 5, that's irrational, and then the rational numbers are minus 6, 2.5, and minus 24 over 5. Okay, next, complete the statement using less than or greater than. Square root of 49, that's 7. So which one is greater, 7 or 8? Or 8.3? 8.3 is greater, so it's less than. Next one, square root of 37, that's a little more than 6, right? Because 6 times 6 is 36. So this is a little more than 6, but it's not 6.5. So it's less than 6.5. So 6.5 is greater than this. How do I know that? Well, we know that because on one side we have square root of 36, on the other side we have 49. So square root of 37 is between square root of 36 and square root of 49. Square root of 37 is very close to square root of 36, so it's 6.1 or something, 6.01 or 6.0 something, or 6.1 something. It's not going to be 6.5. 6.5 is something like square root of 49 minus 36 is 13. Half of 13 is 6.5, so about 42 or 43. Square root of 42 or 43 is 6.5. So we say 6.5 is greater. Then this is like 6.1 or something like that. So approximately. And then 17, square root of 9, it's going to be greater than 3 because square root of 3 is square root of 9 is 3. This is greater than square root of 9. This is square root of 12. So this is going to be 3 point something. And then this is 2.3. So this is greater. Square root of 12 is greater than 7 over 3. Evaluate the expression for the given value of x. So for number 18, when x is 16, we have to evaluate this expression, which is 14 plus square root of x, or square root of 16 in this case. And this is 14 plus square root of 16 is 4. 4 squared is 16. So 14 plus 4, 4 is 18. Number 19, we have minus 9 times square root of x, and x is 25. So this is minus 9 times square root of 25 is 5. We have multiplication of negative and a positive sign, that's negative. 5 times 9 is 45. Number 20, a local park is in the shape of a square. Okay, so we have a park, that's a square, and in a square, all sides are equal. So the area of the park, so the area of the park is 3,600 square feet. So we know that area is always whatever the unit is squared. Find the side length of the park. So find A, and we know that the area is a squared. So a squared is basically 3600, or just a is square root of 3600. Or what is square root of 36? That's 6. And then 2 zeros come out to 1 0 outside of the square root. So square root of 3600 is 60. So the side length of the park is 60 feet. That's 20. 21, wall poster. You're considering buying a square, again square, wall poster that has an area of 6.25 square feet. Find the side length of the wall poster. Same thing, right? So a squared equals 6.25. A is square root of 6.25. Now, what's square root of 625? 625. That's 25. So this is going to be, but there is 2 decimals, 1 decimal here. So 2.5 feet is the answer. Okay. That is 21. And then 22, road sign. The US Department of Transportation determines the sizes of the traffic control signs that you see along the roadways. The square Pennsylvania state route sign at the right, this one, has an area of 1296 square inches. Find the side length of the sign. Okay, so same thing. Same thing. So we have a square. All sides are equal. We have the area. So a squared is 1296, or just a is square root of 1296. And this is probably going to be 36, if I have to guess. But let's see. So 36 times 36. 6 times 6 is 36, 6 and 3. 6 times 3 is 18, and 3, 21. 3 times 6 is 18, 8 and 1. 3 times 3 is 3, and 3 times 3 is 9, and 1, 10. So we have 6, 9, 2, 1. Perfect. Okay, 36. And how I knew that? Well, I know that 6 times 6, the last digits, 6 times 6 is 36. They end on 6. So I saw the 6 here, and I know that 30 squared is 900. And 40 squared is 1600. So I know that the number is between 30 and 40. So I know the number is between 30 and 40. And then I looked at the last digit, and I figured it's probably 36, because 6 times 6 is 36, ends on 6. But you can try a couple, or use the calculator, of course. But if you can't use the calculator, then you have to do this. This is inches squared, so this is just inches. So that's the side length of the sign. That's for number 22. And 23, flower bed. You're building the square flower beds shown using railroad ties. You want to place another railroad tie on the diagonal to form 2 triangular beds. Find the length of the diagonal by using the expression. The expression is square root of 2 times s squared, where s is the side length. So s is the side length, and that is 5 feet. Round your answer to the nearest tenth. So basically, we just have to solve this expression by substituting 5 for s. Okay, so this is gonna be square root of 2 times s is 5, so 5 squared. So this is square root of 2 times 5 squared is 25. 2 times 25 is 50. So square root of 50 is 7 squared is 49. So this is going to be a little over. So the square root of 50 is 7.07, or that is 7.1 feet. And that's the length of the diagonal. So that's our answer. So that's all for today. Please like, share, and subscribe, and I'll see you guys next time. Bye-bye.